rates and forward rates. So this is going to be a separate discussion on par rates and a separate discussion on forward rates. Let me just give you a little bit of a high level introduction to these two so that when we get into the material regarding both, you are able to put in the pieces in the relevant place in your mental map. So what is par rates? Let's say if a bond is trading at par, so the future value is 100 and the present value is also 100, which means it's trading at par. So what is that payment amount? What is that payment amount that will be coming in at these different time periods if we were using the zero rates or the spot rates to do the discounting? So what are we saying here? We're basically saying that the intrinsic value that we were calculating of the bond using the zero rates for each specific, using the respective zero rates for each specific year, if that value was actually equal to par, if the bond was trading at par, which means the present value is the future value, which is the par value, right? Then what would be that payment amount as a percentage of your par value? So essentially you're calculating for the coupon rate over here, right? What would be that coupon rate that will make the present value equal to the par value, right? If you're using the zero rates to discount, and that is your par rate. Your par rate is that coupon rate which will make the present value equal to the par value. And you do this calculation for different bonds, right, of different maturities. So if this is a 3-year bond, then the calculation will be done like this with the face value coming in the third year. But if for a 4-year, it will be different. For a 5-year, it will be different. And whatever those coupon rates are, that is what will make your par curve. That for each different bond with different maturities, what would be the coupon rate to make the present value equal to the par value? And that is how you get your par curve. Forward rates is a different discussion. So let's say you have the rate, the spot rate for a 1 year, the spot rate for 2 years, and you want to calculate the rate for a 1 year starting after 1 year, right? So this is an example of a forward rate, and we'll get into the discussion about how you can calculate this rate using Z1 and Z2. And then we will also talk about how you could, if you have Z1 and you have this forward rate, can you calculate Z2? So we'll get into that, but step by step. First, we're going to talk about par rates. And then we'll do an example on par rates, and then we'll get into forward rates. So par rates are basically that coupon amount which will make the present value equal to the par value or the future value, right? And but basically talking about hypothetical government bonds here, because if you would take other bonds and their payments or cash flows, then every bond is different, every corporation is different, corporate tax could be different, right? There could be other distortions such as liquidity differences. So that's why we don't get into using other bonds for this type of analysis. We are talking about government bonds only. So par rate is basically that rate of a coupon on a government bond which will make the present value equal to the future value. So what is that coupon rate? That is what we solve for, right? That is what we solve for in the par rate. And of course, the present value will always be at par. So that is something you have to remember and just solve for PMT. So I'm going to give you an example. This is coming from the curriculum, right? And here it is. So please pause the video and try to solve for the PMT, right? The coupon rate is what we need. If you are dealing with a 1 year bond, which means the future value will come after 1 year, or a 2 year, which means the future value will come after the second year. 3 year means future value will come after the third, and the fourth one means the future value will come at the fourth year. So what would be the PMT for all of these respectively? Pause the video and calculate the PMT, and then calculate the PMT as a percentage of par, which is the coupon rate. That's what you need to calculate. The coupon rate will be the par rates. Okay, so pause the video please if you haven't already done that, and try to solve these. All right, so here we are. For the first one, it is 5.263, right? So that's your Z1. So 1 plus that, and you're discounting back your payment and your future value with that much. So the payment is going to be that same amount. So for the first year, clearly the Z1 is equal to the par rate for the first year. But the second year is different. So your second year Z2 is 5616, whereas your par rate is 5606. So now you see what's happening is that if this is my, let's say, my zero rate curve or my spot curve, right? If this is my spot curve, observe what is happening. So my Z1 is the same, right? It is the same as my P1, and that is 5.263. But look what happens to Z2 versus P2. So Z2 is 5616, but my P2 is 5606. So P2 is less than Z2. So your spot curve, par curve is lower than your spot curve, right? Even I can prove it for you for the Z3. So if you take Z3, your Z3 is 6.359, but your P3 is 6.306, which is less than 6.359. So your par curve is lower, it's less than your spot curve, right? This is something you have to remember, because in the next section, which is number 4, we're in 3 right now, but when we get to number 4, you will see that the par curve is lower than your spot curve when your spot curve is upward sloping. This would be the opposite situation if your spot curve was coming down, and you can take an example for that and see it. It will be like this, that your par will actually be higher than your spot. And one more thing which I'm going to emphasize more on when we get to your forward discussion is that the forward rates is always going to be higher than your spot curve if it's upward sloping, and it will be lower than your spot if it was downward sloping. So spot is actually always between the forward and the par. Spot is always between the forward and the par. If it's upward sloping, the forward is leading, right? If it's downward sloping, again the forward is leading, but to the downside, right? And that's something we'll talk about in number 4. But right now we are in number 3. So let's focus on that, and then we'll get to the 4th section. So now 3.2, forward rates from spot rates. So this is where you need to be able to understand that if you have Z1 and if you have Z2, right, what would be that rate for 1 year after 1 year? And what does this mean? What does this even mean? So let's say Z1 is 2% and Z2 is 3%, right? So if I were to put in $1 in a bank today, I would have my $1, or let's say if I put $100, it would become 102 if I invested it for 1 year. But if I wanted a higher rate, if I told the bank, hey, I'm going to invest for 2 years, they would say, okay, we'll give you 3% per year. So then I would have that 103, and then on that 103, I would get a higher interest. So what would my investment become if I went for that 3-year, so that 3%, which is the 2-year rate, which is higher. Now, let's say I don't go for that 2-year rate, I go for the 1 year, and then I reinvest this 102. Now, what would be that rate at which, if I reinvest, the amount of money I get in my account is the same I would have had if I had gone directly for the 2 year? And if you equate those two, you are able to solve for this, right? And that is what we're going to basically do. That, let's say if your Z1 is 2% and your Z2 is 3%. So either you put in $100 today, you get 102, the 2% interest, and then what would be that rate, that X rate, that if you earn, and let's call it 1Y, because it's the rate after 1 year for 1 year, what would be that rate that would make the ending balance equal to the ending balance if you invested your money at the Z2 rate, right? And how do you calculate that mathematically? So on one side, you're taking your $100, you're investing it at the 2%, which becomes 102. How do you get 102? Well, you multiply the 100 with 1 plus 0.02, right? And then what that X rate is going to be, or what that forward rate is going to be, is what you need to find out. So you multiply that ending balance with 1 plus that forward rate, and what you should get is the rate if you were to invest for 2 years at 3%, right? So that's why the square, because obviously it's going to get multiplied with itself. And if we were talking about just $1, right? So that $1 grows at, so let's say this is 1 multiplied by this and then multiplied by this. If it was 100, then obviously I'd be multiplying 100 on both sides. But there's no point of doing that. You can just assume it's $1. And what you're basically saying is that if I invest $1, it grows at 1.02, and then it grows at 1.0x, right? Then it becomes equal to 1 plus 0.03 squared. And you are able to solve for that rate, which is going to be 4.0098, which means your 102 will then get your 1.02, because it's that $1, which becomes 1.02. You earn 2 cents interest on it. Then will be multiplied by 1.040098 to tell you, to make it equal to that $1 invested at 3% for 2 years, right? This is what is a forward rate. Now, why is it so important? And do we usually calculate forward rates from spot rates? Well, the answer is actually we are using forward rates to imply the spot rates, practically speaking. And why? Because forward rates are quoted for various maturities, almost all maturities, by a lot of different financial institutions. And why is that, right? So a lot of businesses actually want to lock in future rates for borrowing or lending. Let's say I'm a business and I'm planning a big project and I don't need money right now, but I know I will need money in the future. But I need to know what that money is going to cost me, because I need to build it into the feasibility, right? And that's why I need a forward rate quotation. Now, financial institutions, big banks, are always giving forward rate quotations to large corporations, manufacturing companies, businesses. And therefore, from a yield curve construction perspective, either you can take the spot rates and make your yield curve. But we talked about some practical limitations of spot rates. What were those? Yes, you are right. They are not available for all maturities. So we saw that there was a big gap between the 10-year and the 30-year maturities that the government is not issuing between those. And also only the on-the-run securities were actively traded, off-the-run securities were not that actively traded. On the other hand, with respect to forward rates, you have these financial institutions quoting forward rates for various maturities, and you could very well imply the spot rates from that, right? So let's say if you knew what Z1 is and you know what the rate for a loan starting after 1 year for 1 year is, which is the F2 that we just calculated, right? And you don't know the Z2? Well, you could very well solve for Z2. If that 3 was the x, right? If this was the unknown here, so 1 plus, let's say, x, or let's just call it Z2, right? If this was the unknown here, you could very easily solve for that. And that is what is done, practically speaking, that you use the forward rates to actually solve for the spot rates, and then you can make the curve. And just let me emphasize on the notation here. So this is going to be 1y, which is for the rate for a this is the rate for a loan starting after 1 year for 1 year, right? So this is the 1 year rate for a loan 1 year from now. If let's say we wanted something way into the future, or just a little bit into the future, but for a longer period of time, so that would be 2y, 5y, which is the rate for a 5 year loan 2 years from now. So if it was starting here and then going for 5 years into the future, right? So that would be, let's say, 3, 4, 5. So if this is 3, 4, 5, then the rate starting after 2 years and then going for another, actually, this would even go up to 7. So 3, 4, 5, 6, 7. Yeah. So the rate for a 2y, 5y would be starting after 2 years and then going for 5 years. So that's the rate you can calculate if you have your rate for 7 years. So if you have your Z7, you can calculate that. And the way that would work is, I would say 1 plus Z7 to the power of 7 would be equal to my 1 plus the Z2 to the power of 2, which is 3%. This is my Z2, plus 1 plus the X rate. Let's say I call it X to the power of, and that's going to be to the power of 5, right? So I can actually calculate for X if I have my Z2 and Z7. So this is how this whole relationship works. Right. And you could then use forward rates to imply spot rates, right? So then you could use those spot rates to calculate the bond price. So we know the value of a bond is the intrinsic value of a bond that we want to calculate is your future cash flows discounted back at your spot rates, Z1, and then Z2, and then Z3 if it's a 3-year bond. But if you don't know Z1, well, Z1 you will always know because that's equal to the par rate, which will be equal to the forward rate. But Z2 and Z3, if you don't know Z2 and Z3, you could calculate Z2 using Z1 and the forward rate, right? So Z2 can be calculated using your Z1 and the 1y rate. You can use those two by saying 1 plus the Z1 to the power of 1 multiplied by 1 plus the 1y rate also to the power of 1 will give you 1 plus Z2 to the power of 2. So you can calculate for Z2 like that. Right, and then similarly you can calculate for Z3, and then you could plug those in and calculate your zero rates. So let's have a look here what's going on. So we've got these forward rates, and let me draw them for you. So we've got a 0y, 1y, which obviously is going to be Z1, which is 1.88%. Why is 0y, 1y Z1? Because it's starting now for 1 year. So that is obviously the same thing as Z1. But everything else is forward purely. So the 1y is 2.77%. And then the 2y, 1y, which starts after 2 year for 1 year, is 3.54. And then the one that starts after 3 year for 1 year is 4.12. And now if you want Z2, well, you could just calculate Z2. It would be this 1 plus this multiplied by 1 plus this. And that is what you see over here, right? You can calculate for Z2, you can calculate for Z3. So Z2 is from here till here, and then obviously Z3 is going to be till the third year. So you'll just take all three of those and calculate Z3, and then you can similarly do that for Z4 as well, right? So that is how to calculate spot rates using forward rates, and forward rates are quoted in the market for all maturities, so you can easily do that. And then you could then plug in those Z2, Z3, Z4 that you've calculated using your spot rates, so using your forward rates to calculate the intrinsic value or the bond price, right? So what we have essentially done here is we calculated this Z2 and Z3 and Z4 using the different forward rates. So that's basically what's going on. Right, so let's take a break here. You can maybe watch this video again just so that your understanding of par rates and forward rates is clear before we get into the relationship. The relationship is actually very, very simple and straightforward, but nevertheless, let's take a break. You watch the video again, make sure you understand the concept, and then we'll cover the last part of this learning module, which is the relationship.